we realize there are a lot of things that you can do with your time. So we really appreciate the fact that you came today, and we hope to give you information that is going to help for 2023, not only managing tar spot, but I'm really excited about what Brad's going to talk about. Today we're going to talk about tar spot, and we're going to look back and sort of do almost an autopsy of what happened this year. Brad's going to talk about something that's very predictable looking forward and what we can do with that. So with tar spot, it starts so innocently. My first look at tar spot was the first week of August over by Hampton. And then I spent the rest of August, September, and October until harvest was completed, basically walking fields and looking at this. And when I first saw this, and I knew what the history was, in 2015 it was a bad thing in Illinois and Indiana, and it could go it progresses really fast. And I looked, there's 4 little dots on here. This isn't any big deal. The next week, when we went back, okay. Yeah, it kind of does look like you took some kind of a device and sprayed tar on this leaf. And about 17 days later, we started seeing this. Now, what was really interesting about this whole scenario was that I've been an agronomist for 42 and a half years. I've seen northern corn leaf blight. I've seen gray leaf come in. I've seen all kinds of disease in my career. I've never seen a disease that from the first week of August to the end of August could do this. So that was the first thing that I thought, we need to take a look at that. And so Jason was the first who talked about tar spot, and then the rest of your team got very involved between Bruce and John and Larry, and doing some trials. And I'm gonna do some trials, we did some trials, and we're gonna go over what we found there. First, I just want to kind of show you what we saw and what the life cycle of this disease is. I love this shot because if you look at this, you can see this is center pivot, and you can see that where the water was applied was where the tar spot, obviously this was not sprayed, there was no fungicide applied here. This is basically what happens with moisture and the right conditions environmentally for tar spot to occur. So as I said, in 2015, it was just a little bit of a challenge over here. By 2011, it had spread pretty significantly. At the end of this year, I'd say late September, early October, I traveled 18 to 20 counties right from the north central, northeast, all the way down through Des Moines in the entire territory of Landus. And I found tar spot in every single field. Now, it came in late, and so it wasn't necessarily going to cause a challenge, but it was building that inoculum for the next season. And that's really what we want to spend time on. Here is the life cycle of tar spot. And the main thing you have to look at is right here, depicts the residue. So you all got residue out there. You've all got those stromata, which are those black spots on the leaf. They overwinter. And when we get moisture and the environment that favors the development of the spores will develop and they'll go into the plant. The challenge with this is that you don't see it visibly on the leaves for 14 to 21 days. So it's got a 14 to 21 day head start wherever it started, usually on the lower leaves, working through that plant system, which makes scouting very, very difficult. And you're going to see that with some of the examples that we used. So the conditions that favor tar spot: cool temperatures, high humidity, prolonged leaf wetness. Keep in mind, we had areas of the state that had less than 10 inches of rain the whole growing season, which is different than what we experienced here, but I'm talking about northwest Iowa. They had tar spot come in also, because you can get all these conditions above. If you look at where I've got it circled in red, it can all occur during the nighttime hours over a 7-hour period of time. Wet leaf, heavy dew, humidity will cause the spores to go, and they'll go from leaf to leaf and work up the canopy. And this cycle will repeat. As long as we have the conditions, it will repeat over and over and over again, and I think that's why it's such a difficult disease, and why from onset, in some years with the most susceptible hybrids, you can have a hybrid have a few spots on it, like I showed in the initial slide, and 17 days later have complete senescence of that plant. If that occurs in August, we're having yield loss because we're not getting to black layer and the plants are shutting down. So I wanted to bring a live example, and John Boss was nice enough to have put this together. And so here was a spot at New Hartford, not too far away, where we did a trial. And it was sort of a late season trial when it started coming in, Jason. You can see here from the as-applied map, this is where the treatment was in this field, so we left this side and this flank untreated. What we found interesting is when you look at NDVI images later on, you could see that obviously there was more plant material here. And when John showed me these couple slides, I said, I gotta come up and look at it. John, do you remember what time it was at? The end of August when we came in. So these next few videos that we're going to show you, because I really believe that seeing is believing. Guy king up here, talking head all the time, but we actually wanted to show you what it looked like. Now this was TrivaPro applied, and you could see as we were going through that, maybe I'll show you that again. Okay, it's nice and clean up here, but look as we go deep in the canopy, we got tar spot. Why is that? So remember I said, when the cycle occurs, it's 14 to 21 days before, once it's infected the plant, that it actually, you see the symptoms. Another point about tar spot is this, and this was something that the university consortium put together. They looked at percent infection, which, I mean, you know, these black spots, how do they determine whether it's 5%, 10, 20, 30, or 40? Well, they have an online portal you can go to, and they run a test. They'll throw a test at you, and they'll show you a bunch of spots, and they have a multiple choice, and you guess that this is 10%, this is 5%. And it's just a learning thing. As you look at them and you go through this thing, you start saying, oh, I've got this. 40% is the magic number of amount of that infection and those black spots on the leaf, which will cause the leaf to senesce, shut down. So once you get to that point, that's when the leaves start shutting down, and if they're shutting down in August, it's not a good day. So you could see we saw some here, but when we looked at the area that had no fungicide applied, look at the difference between that first slide and this one. Yeah, it was in the lower canopy, but it also was in upper canopy. This is in August, and we're definitely up to over, that's 60, 70% senescence. There you're getting into that about 40 where you see it starting to turn brown. The entire plant is infected. This is late August. So this progression went from the first week of August when we saw it to late August, and that's what it looked like. Now I want to go back and show you the TrivaPro one again. Okay, so you can see we've got it on the lower canopy. So obviously we weren't able to protect that, and fungicide would be hard to get there, but we did protect the top half of the canopy. Where is most of the photosynthesis occurring? At that point in time. You want everything healthy above the leaf. Obviously we like to keep the whole plant healthy But we did protect the top leaf because the top of the plant, because you see we're pretty good here. And the yield difference was pretty significant. Here is now just another visual looking at, and this was right at the split. We saw that first as applied map, and you saw where the one area was definitely not as healthy as the other. So you can see the difference where it was applied at VT and where it wasn't. John flew the drone, and I thought this was pretty interesting. This was pretty telling. So you could kind of see where the application was, and as we went over there, you could see almost right to the line. Healthier than the other side. John, I don't think I even put down here, what was the difference in yield?
So there's a couple different hybrids out there.
Yeah.
The hybrid was 21 bushel, the other was 26 bushel.
Okay. 2126, so that was New Hartford. Here was a plot, which the reason I'm showing this one is because it was interesting. This was at Lake City, which is kind of south and west of Fort Dodge, where I live, about 30 miles, and they had very limited rain. They probably didn't have over 14 inches, where some of you had in the 21 to 25 inch range. And so you could see, we found this also in early August, and this plot had been sprayed at VT. So it had been sprayed in July at tassel time, but we saw tar spot coming back in. And this plot demonstrates differences in hybrid tolerance, and that's why I'm showing you this. You can see visually, obviously there's some differences. Here's what the yield data showed us. Now, I'm not here to sell you one product or the other. I'm an agronomist. I don't sell seed. I am a detective in a sense. I go out and I look at fields and try to figure out what's going on. It might sound cheesy, but it's like a CSI thing, only it's crop scene investigation. That's what we do. That's why I've loved agronomy for all this time, Jason, and stayed in it. So if you remember, this product here still had plant health. This one here had shut down. There was tremendous tar spot here right to the line, and there was a difference in yields about 20 bushels. That is after we had already sprayed it at VT. So my bottom line recommendation for you here is tolerant hybrids do help and make a difference. So that's the first thing that you should look at when you're looking at placing products next year if you're worried about tar spot, is find those most tolerant products. That doesn't mean you will not have to spray if tar spot comes in heavy, because I also saw by the time we got to the end of September, it pretty much would get into most things from the bottom to the top. It's almost like what we did with application, and I even almost hate to use this word because it just, but we extend, I'll say it this way, we extend out the time the plant stays healthy before it starts shutting down and try to get past a black layer. I was going to say another word I didn't want to. Last slide I have on this, this was a plot that John did at Dyke. What I found on this one is I highlighted the ones in yellow because those were products that I probably have 500 hours of video. If anybody wants me to come out and show you video of plants with tar spot from various plots all over the place, I do that as an agronomist because when I come back to a plot, I like to see what it looked like looking at the yield. And so and looking at all of those summaries, these had, in the yellow, had the best tar spot tolerance all season long. You can see the average yield, and the ones in the blue had poor tar spot tolerance, and you can see just the difference in this plot. So you can take slice and dice plots any way you want, but I thought this was fascinating. Obviously, there might be some other things going on there, but I don't think after this season anybody would argue that tar spot is a significant thing, and we have to look at managing it for 2023. Some hybrids have better tolerance than others. Okay, those products that are highlighted here, had the highest rating, according to the university people, for tar spot tolerance in their trials. Most of these products did really well, but those were the best. Now, I thought John did pretty good with his TrivaPro. And so my thought was, what's the difference? So what we found, and I don't want to get too much in the weeds here, but my bullet statement up there in the far left, I say the group 7 component for the fungicide mode of action tolerance is important in preventing tar spot. That's your strobe. You got triazoles and you've got strobes. Those are your basic ones. And then you got the SDHI for rust that Syngenta brought in with TrivaPro. But most fungicides that have two modes of action will be an 11 and a 3 modes of action. The 11, the strobe, is preventative. And it will give you preventative features for anywhere from 5 to maybe 10 days at the most, depending on the concentration. What we found interesting is when you look at these products, the ones that were rated the best for overall suppression of tar spot had the strobilurin concentration in that mix over 14%. Now, TrivaPro did well, but it's only 11.7% of the strobe. So what we were saying is that you add 3% azoxystrobin to a TrivaPro, you're increasing the preventative measure. And it's just like weed control. The best weed control is not seeing anything, seeing bare ground from pre-emerge to post, just overlap and just get rid of it. With tar spots, the same thing. You do not want to see any of these guys. It takes 14 to 21 days from infection to the time when you can see them. So if we're looking at a year and it's plenty of rain in June and the temperatures and everything is favoring tar spot, you can do what you want, but guys, using that extra amount of azoxystrobin, the strobilurin, 3 or 4 ounces, you can do a generic, very inexpensive, might be the best thing you do to keep it on the preventative side, keep it from getting worse. That's one of the things that we found from this year. I'm going to say that when you're looking at these best tar spot tolerant hybrids, 1 time will probably be enough. If you've got a favorite hybrid out there that's been your gunslinger, this thing is offensive and it just really goes to town for you, and you've escaped having significant tar spot, but you go into a year where it comes in early, what if we start hearing about tar spot in July this year instead of August? And we have the temperatures and the conditions that favor it. So if you have a really good favorite hybrid that's not very tolerant to tar spot, then I think two applications is probably going to have to happen. If you have something that's very, very tolerant, you can get by maybe with 1. So here's the thing. How are you going to know which ones are tolerant and which ones aren't? Not everybody is putting that information in their seed guides. You need to work with somebody like your team here that you have account leads from Landus, because we have spent a lot of time sending out information to everyone based off of what we visually saw. I think we have a pretty good handle on the agronomy side. Hennessy, he knows what to recommend John, the whole team. So that, to me, first things for management for 2023, figure out what hybrid you're planting. I'm not going to say completely change what you're planting. We may not have tar spot next year. It doesn't happen every single year. But if you've got corn on corn and you had heavy tar spot, you definitely might want to go with something that we know is pretty tolerant. So get your genetics figured out, and then just, you're going to have to plan probably for a VT for sure, and you might need something later on depending upon the susceptibility of the hybrid. So that's how I would, some of this is based off of what Illinois and Indiana have taught us. Go ahead. The tar spot data that we've collected is visual data because it's a visual product. So you go out, so I go out Plainfield plot or the dike plot, and we go out once a week, and I use video, and I just go down, and that's basically how I do it. And I did in every plot that we had. So for this season, it was a lot of walking, and like I said, hours and hours. I do think that the seed companies are going to be able to figure this out. Brad might be able to speak to it because he worked with Bayer, and they're going to be able to find that correlation of what the genetics are and what kind of, whether that translates out. There are companies out there who talk about their plant health all the time. There are companies that people have used fast dye, fast dry. I'm not gonna, I don't want this to turn into, so you guys are smart, you can probably figure out who I'm talking about. I will give you my opinion, it's just one opinion, and that is those companies that have talked about plant health over the last few years do seem to be able to tolerate and maintain that plant health longer into the season. That's what I saw, and that seems to be translating. But everybody has a few products that seem to be better than others, and some companies seem to have a higher percentage of hybrids that are in that. If it's that fast dye, fast dry, that I would want to be very careful next season, and I would want to watch those plants. I would want to scout very aggressively if we have wet conditions in June going into July, and be ready to pull the trigger on fungicide on those products, because there have been a lot of talks on the social forums and social media, and people are saying, hey, don't go away from your high yielding genetics, and part of it's marketing, and I totally get that. But you're playing a very dangerous game, guys, if you think you're going to be able to get by when the conditions are right and not use any fungicide with tar spot when it comes in, and those susceptible hybrids, they go down quick. 20, 40, 60, 80 bushel differences. I don't want to be too hyperbolic with this, but it's a big deal. So I hope that somewhat answers the question. There are differences, and we're seeing differences. We're using more visual differences, I think, in the next couple of years because of the ability with biotech and everything else. They're going to be able to find whatever that gene sequence is that's given better plant health and tolerance and do that. But for right now, for what you guys are looking at, everybody on this team that invited you to this meeting knows which products we positioned as more tolerant than others, and they will tell you that, and that's what I would go on